Hi everyone. In this video, I want to explore the idea of a 3D geometry that only requires one mate for it to be fully constrained in 3D CAD. Firstly, if you don't know me, my name is James. I'm a product design engineer. Now let me explain a little bit what I'm talking about here. So I'm here in Solidworks and we have one rectangular box here which is fully constrained, which means that it's fully fixed in 3D space. It can't be moved. And I have a 3D cube here, which is completely free, as in it's floating and it's not constrained in any dimension. Now, in the world of 3D CAD, we have something called a mate, which is where you can tell two faces, two edges, 2 points to have a certain relation to each other. And this allows us to fully constrain one 3D geometry to another. So if I want to fully constrain this cube, generally that means I need to add 3 mates to it. I need to limit the axes that it can move along. So I can add a mate to the bottom face and to the top of this face. So that means that it can no longer move on the Z axis, or in SolidWorks' case, the Y axis, which is up and down. So it can move on the Z and X axes, but not the Y. And that's more obvious if we look from the front. So we can see that it cannot go up or down, it can only move on this plane. Now, if I want to continue constraining it, I can add a mate to this face and this face, which means now it can only move along the X axis. So we can add one third and final mate on these two faces, and now it's fully constrained. So as you can see, the component is fully defined and it cannot be moved, meaning it's fixed in space. Let's take a look at another example here. So we have a base with a cylindrical peg and a cube with a cylindrical hole. I can add a mate to the cylindrical face on both of these objects. Now the cube is constrained along the axis of this cylinder. So it can rotate and it can move up and down along the y-axis. So if we want to prevent that rotation, we need to mate one of these faces to be parallel with this face. So that's prevented the rotation, but it can still move freely along the y-axis. So I need to mate these two surfaces together, and now it's fully constrained. Here's a third example. So we have a sphere here, and we have a cube which has a spherical cutout in it, as you can see in this section view. This spherical face can be mated to the sphere, but it can rotate still in every direction. We don't have any other faces of the sphere that we can mate this to, so we'll have to mate it to our planes. So I have a top plane here, I can mate that top plane to be parallel with the coordinate system top plane, and I can mate the front plane to be parallel with this plane. So now again, the object is fully constrained in 3D space with 3 mates. So this is generally how mates and constraints are taught. But what if there was a type of geometry that didn't need 3 mates to fully constrain an object? What if you only need 2? Here's a situation that you might have run into if you're familiar with CAD. We have here a plate with a screw hole in it, and that screw hole is countersunk. And we have a countersunk screw. In this case, I can add a mate to the countersunk face, or the conical face of this countersunk screw, and mate it with the conical face of the countersunk hole. Now this is constrained in the y-axis, also in the x and z axes, but it can still rotate on the y-axis. So we need to add one extra mate. If I mate the right plane of the screw to this edge of the plate, it's fully defined in space with only 2 mates. So this got me thinking, if it's possible to fully constrain an object with only 2 mates, could it be possible to fully constrain an object with only 1 mate? What kind of geometry would that be? I think I have an answer. Let's check it out. So here I have a base plate again, which is fully fixed in 3D space. And I have this floating plug, which can fit inside the hole in this plate. Now the hole in this plate, if we look at the section view, is actually conical. So it's like our countersunk screw where it's cone shaped, which automatically allows us to reduce 2 mates down to 1. But the other unique thing about this hole is that it's an elliptical shape. Now, technically, an ellipse mated to an ellipse would prevent it from rotating, because this face would be fixed either in one position or the exact 180 rotation of that. But we have a problem. If I try to mate these two faces together, nothing happens. But why? This is a problem related to CAD software. Now this matrix shows the different types of geometries that can be mated to each other with a coincidence mate. Now we've mostly been using plane on plane mates, which you can see are compatible. Cylinder on cylinder is not compatible, but we actually used a concentric mate for that. As you can see here, sphere on a sphere is also not possible, but we also used a concentric mate for that. as you can see here. Now in the countersunk screw example, we actually did use a coincidence mate, and you can see in the matrix that a cone is compatible with a cone, but a surface is not compatible with a surface, and a curve is not compatible with a curve. If we look at the concentric mate, you can see that here a cone is also compatible with a cone, a cylinder is compatible with a cylinder, and a sphere is compatible with a sphere. But nowhere in this matrix do they allow for an elliptical cone. That doesn't fall under the types of geometry that would work for a concentric mate or a coincidence mate. So it doesn't work on a technicality. But we do have one way that we can cheat this. There is a way we can do one mate to fully constrain this floating object, and that is by mating its origin to the coordinate system origin. And that does fully define the object, but that could work for any object. But what I wanted to get out of this is that this geometry technically would be able to be fully constrained with only one mate, if that mate was compatible. As you can see, it fits perfectly. There's no way that it could rotate or translate in any direction. So what do you think? Am I right? Is this true? Can you think of any other geometries that could be fully constrained with a single mate? Let me know. If you can find one that works in Solidworks, I would love to see it. Anyway, this was just something that came into my head. I thought it'd be fun to share. Let me know what you think. I hope you have a great day, and I'll see you on the next one. Thanks.